Here on the Marquette Iron Range in Michigan's Upper Peninsula, Cleveland Cliffs, Michigan operations consist of 2 mining areas and 2 processing plants. The Empire facility began operations in 1963 and processes magnetite iron ore. The Tilden facility began operating in 1974 and is the only iron ore facility in the world that can process both magnetite and hematite ore. The 2 facilities are capable of producing 13 million tons of iron ore pellets each year.
That's accomplished by mining iron ore that's about 35% iron. That iron ore is then processed into pellets that are about 65% iron. The pellets are then delivered to North America's steelmaking plants where they're fired in a blast furnace to create molten iron. The molten iron is then used to make steel.
There are several steps involved in mining and processing low-grade iron ore. In the mining area, the ore is mined from the ground, crushed, and then sent to a processing plant. In the concentrating plant, ore grinding creates an extremely fine concentrate. 90% of it is finer than 1/1000th of an inch. The iron mineral is liberated during this process, creating a high-grade concentrate. In the pelletizing plant, the concentrated ore is rolled into balls and heat hardened in large kilns at 2,400 degrees Fahrenheit, creating finished iron ore pellets to be turned into steel.
To produce iron ore pellets, all 3 departments, mining, concentrating, and pelletizing, must work efficiently. All 3 play a major part in turning what was once worthless rock into a valuable product. Let's take a look at that process, beginning right here where the ore is mined.
Mining follows a plan developed by engineers to remove and store the millions of tons of material that cannot be processed in our plants, while providing access to the millions of tons of crude ore that must be mined from the ground. Once a plan is developed, mining begins by drilling 16-inch diameter blast holes on engineered blast patterns. A blast pattern can include up to several hundred holes, each 50 feet deep. About 3,000 pounds of explosives are pumped into each hole. Then, following proper safety procedures, blasts are detonated 2 or 3 times a week. An average blast breaks about 500,000 tons of rock and ore, which allows loading equipment to move in to begin the next phase in the mining process. Electrically powered shovels load the broken material into 240-ton production trucks with about 70 tons per scoop. A shovel can load a truck in about 2 minutes. The loading fleet also includes some of the largest front-end loaders in the world. These large loaders provide the mining group with more flexibility in moving to and from digging locations in the 2 main mining areas at Tilden and Empire. To haul the ore and rock, a fleet of about 30 production trucks is used, each able to carry up to 240 tons per load. When loaded, the trucks are off to one of 2 destinations. Those filled with material that can't be processed in the plants are sent to one of the mine's rock stockpiles. Trucks carrying ore are dispatched to a primary crusher. Here the ore is dumped into the crusher where a gyrating mantle crushes it, reducing the ore to pieces smaller than 10 inches in diameter, ready to be ground even finer in the concentrator portion of the plant. Mining operations function here 24 hours a day, 365 days a year, and it's important for the mining area to achieve optimum productivity. To do that, mining operations are monitored and controlled by a pit dispatch center. Computers are linked to the shovels and production trucks at both the Tilden and Empire mining operations, providing the necessary data and guidance to maximize pit efficiency. Additional mining functions are supervised here, and the dispatch center is an important part of communication between mining operations and the next step in the process, the concentrator plants.
We're now in the concentrator portion of one of the processing plants. Here, the ore that was mined in the pit and reduced in size in the primary crusher is going through a grinding process to reduce it to an extremely fine consistency so the iron particles can be liberated.
That process takes place in grinding mills. Crude ore and water are first fed into large primary mills where the tumbling of the ore inside eventually grinds it to the consistency of beach sand. Additional grinding in smaller mills grinds the ore to the consistency of face powder. The water and fine ore create a slurry, which still includes material that must be separated from the iron particles. When processing magnetite ore here at Empire, the ore separation takes place by using large magnets inside rotating drums. The magnets attract the very tiny magnetite iron particles, while water used in the process helps wash away the unusable material. The slurry with the magnetic iron particles then continues in the process. When processing hematite ore at Tilden, separation occurs differently. Cooked cornstarch is added to the hematite ore slurry in large thickener tanks. The cornstarch attracts and gathers together the very fine iron particles. These settle to the bottom of the thickener to continue in the process, while the unwanted material overflows the top and is washed away. At both Empire and Tilden, the ore slurry is also upgraded by a flotation process and is sent to large concentrate thickening tanks to begin the process to thicken the slurry and remove the water. At this point, the magnetite and hematite process remains the same throughout the rest of the plant. The thickened concentrate slurry is sent to vacuum disc filters, where much of the remaining water is removed, leaving a high-grade iron ore concentrate, about 65% iron, which is conveyed to the pelletizing plant for final processing into pellets. Concentrator operations are supervised by skilled employees at both Empire and Tilden, using state-of-the-art computerized control systems to monitor and regulate the processes and equipment in the plant.
Once the concentrator plant has created a high-grade concentrate, that material is conveyed to a pellet plant. Here in the pelletizing plant, the concentrate is rolled into round balls, and those balls are heat hardened at a high temperature in a rotary kiln.
Concentrate is first mixed with a small amount of a clay binder called bentonite. Then it's fed into balling drums. As the material rolls in the rotating drums, it's formed into marble-sized pellets. These unfired pellets are called green balls. The green balls are screened to allow only the proper sized balls to continue in the process. The green balls are too soft for handling and shipping or for use in a blast furnace, so they move to the next phase of the pelletizing process. The green balls are dried and preheated beginning at about 500 degrees Fahrenheit. As they move along a traveling grate system, temperatures continue to rise until the green balls are fed into a rotary kiln. Fired by either natural gas or coal, the kiln temperatures reach about 2,400 degrees Fahrenheit. This hardens the pellets so they can be shipped and used efficiently in the blast furnaces at North America's steel mills. Pelletizing operations are monitored and regulated from a central control room like this one. Operators supervise the process and make any necessary adjustments to produce high-quality iron ore pellets. They closely follow the preferred specifications provided by steelmakers. Once fired and cooled, the pellets are conveyed out of the plant to be loaded for shipment to the steel mills. Pellets are shipped by rail to ore docks at Marquette on Lake Superior or Escanaba on Lake Michigan. There, the pellets are loaded into ore carriers. These vessels, some as large as 1,000 feet long, can carry up to 65,000 tons of pellets. These ore carriers transport the pellets to ports located on the Great Lakes to be delivered to steel mills.
The majority of pellets produced here in Michigan are called flux pellets. That's because they have this flux-stone material, a mixture of limestone and dolomite, added to the pellets here at the mine. The flux-stone helps to remove impurities out of the blast furnace when firing the iron ore. A majority of steelmaking companies like to use flux pellets because they're more efficient in the blast furnace.
Cleveland-Cliffs, Michigan operations can produce more than 13 million tons of pellets per year. The workforce involves more than 1,300 men and women, which includes a railroad transportation division. Total payroll, including employee benefits, is $160 million annually. Local services and supplies purchased total an additional $160 million each year, which includes a combined electric bill of more than $80 million annually. In all, Cleveland-Cliffs, Michigan operations have an economic impact in excess of $300 million each year. But the real key to success here is people. Modern-day mining requires a highly trained and skilled operating and maintenance workforce. Employees are trained to safely operate and maintain the state-of-the-art equipment necessary for maximum productivity. Technical employees work closely with the operators to produce a high-quality product in the safest and most efficient manner possible. A professional safety and environmental department is also important to ensure that production here is accomplished in a safe manner and in compliance with state and federal regulations. Michigan facilities include modern pollution control processes and equipment and work with regulators to minimize the impact on the environment. Steelmakers in North America depend on how the job is done in Michigan because steel really does start here. Producing high-quality iron ore pellets at the lowest possible cost for our customers is the challenge met 24 hours a day, 365 days a year by employees at the Michigan operations of the Cleveland Cliffs Iron Company.